Okay, so hello everyone. Today we will be solving our question of LeetCode's POTD. It's the question of today's POTD, which is minimum recolors to get key consecutive black blocks. Okay, so this is the question, and as you can see, the question number is 2379. Okay, it is marked as an easy one. Now let's see what the question is all about and try to solve it. Okay. So let me just read the description for you. So you are given a zero index string blocks of length n where blocks I is either capital W or capital B representing the color of the ith block. Okay. The characters W and B denote the colors white and black. Okay. So the W means white and the B means black. Okay. So respectively. Okay. So you are also given an integer array k, which is the desired number of consecutive black blocks. Okay. So in one operation, you can recolor a white block. We can recolor a white block such that it becomes a black block. Okay. So we can recolor white block to a black block. Okay. Return the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. Okay. So the question, what does it says? Okay. We need to find, uh, I would say like consecutive seven, like consecutive, like here k is equal to 7. So we need to find minimum number of operations to find such a window which includes k number of black blocks. Okay. So while doing this, okay, so let me just uh, say it more clearly. Like we need to find minimum number of operations in order to get k consecutive black blocks. Okay, and in order to get it, we can change the w to a black block, which will be one operations. Okay, so we need to find the minimum number of operations. Okay, so right, as you can see here, here are the k consecutive black blocks like 1, 2, 3, 4, 5, 6, and 7. So this is the problem statement. As you can see, this is another example, and here are the constraints. Okay, so let me just give you the proper explanation, intuition behind it. Okay, so the question asks us to give the consecutive k black blocks. Okay, so the k is fixed. Okay, so can you identify a pattern in it? Pattern like a sliding window pattern in which the window size is constant or same, it doesn't change. So like here k is equal to 7. So what is k? K is the window size. Okay, k is the window size which is fixed, which is not changing, right? So okay, so the window size initially what it will be? It will be 7. Like as you can see, this is the window. Okay, so we know that we can identify it like this is the problem of a sliding window in which, or I would say fixed sliding window in which, uh, wait, let me just, it is fixed, in which the window size is fixed. Okay, so let's just do the trial and see how we can solve it. Okay? So in the first window, like this is the first window, how many white blocks are there? Like one, two, three. Okay, As you can see, the size is 7. 1, 2, like you can just 6 minus 0 plus 1. Okay, it will be 7. So, which is equal to k. So, in the first window, we have the we have 3 whites. Okay, and okay. So let me just, which means there are 4 blacks. Okay, so there's a window of size 7, and if in that 3 are white, so rest will be black. Okay, so how many whites we need to color to get the window size of 7? Like 4 are already black and 3 are white, so how many do we need? We just need 3, right? So how many colors, so how many to recolor? 3, right? Like suppose if we color this to black, this to black, and this to black, so then what it will be? It will be the window in which there are k elements and all are black. So how many operations? 3. Okay. So what do? We move the entire window for the next set of or what we can say for the next set of elements. Okay. So we move the entire window. Still here the size is same, like 7 minus 1 plus 1 equal to 7. 7, let me just write it with 7. It's too bold. Just a second. Like, yeah. 7 minus 1 plus 7 plus 1 equals to 7. Okay. So the window size is 7, right? Okay. So how many whites are there? 1, 2, 3. 3 white. Okay. So there are 3 whites. It's the same case as before. Like, okay. So how many whites we need to recolor to black? 3, right? Okay. So now we move the window in front. Okay. So the new window is something like this. Like here also you can see 8 minus 2 plus 1. What it will be? It will be 7, right? Okay. So this is a new window. How many whites are there? 1, just a second. 1, 2, 3, right? So we are storing the white. Okay, we are like storing the minimum white also. Like as we are going forward, we're also having this minimum white. Okay, so the minimum white till now is 3. Okay, so now we move the window in front. Okay, so in this window, how many whites are there? 1, 2, 3, and 4. So there are 4 whites here. Okay, so the minimum white which we need to recolor is 3, which can be from either of these windows, like this one or this one or this one. Okay, so it's a very standard problem of sliding window or two pointer also, like we can say. Okay, so yeah, this is the approach. Okay, so let me just show you the code and then we are good to go, right? Okay, we have calculated the size of the blocks, okay, which is n. Now initially the whites will be 0. Okay, so let me just like cover one thing also, one more thing, that why are we not considering blacks? Okay, Why only white? Okay, why not black? Okay, why not black? Because we know that the window size is 7. Okay, so if we know the white size, we don't need to calculate black. Plus, also there's one thing that we can only perform operation on white, right? So why do we need to calculate black, right? Because black isn't making any like impact, right? We only need to recolor white, so that's why we are considering white. Okay, so yes, so now the minimum color initially will be n. Why? Because like suppose they are all whites, right? So the maximum number is n. Then we need to recolor the entire array, na? So yeah, that's now we have taken 2 pointers. One is I and one is j. So to first initially set the window, we are running this loop, right? Till k is equals to 0, right? Okay. So what does this loop is doing, right? What does it do? This is setting this initial window. This one. Okay. This one it's setting. This one. Okay. It's setting this one. So we calculated the minimum color, which is the minimum between the min color and our white. Okay. So now here comes the main loop, right? What we are doing in this loop? Okay, we are moving the window, right? And we are just calculating, like we are subtracting, because see how the window is shifting. We are moving I and j simultaneously. Okay, so what's happening, like if we are moving it simultaneously, so this here is the I, here is the I, right? And here is our j. So the like we have shifted it here, the y at the I will be like initially here. So if we are moving it, so this white we are not considering it. Okay, so if this is a white, we need to remove it from our window, right? So while moving I, we are, if it is a white, we are subtracting it, like we are reducing it, okay? And we are moving j forward, right? J was here, we moved j here, j is like now here. So if this is a white, we need to consider it, right? So that's why we are adding white here, okay? And now here we are just calculating the minimum color which needs to be color, which is the minimum number of like the whites in this window, okay? Like see here the constraints are very low, okay? It's only 100. So any brute force approach will work here. Okay. So like if you don't want to do it like this, you can also run a loop from I to j and calculate the number of whites. Okay. We can also do it that way. But this is a, I would say, an better way or an optimal way. Like if you are moving like then only you can calculate it. But you can do it also that way. That will also work. And we are just moving the I and j pointer. Okay. So at the end, we are just returning the minimum colors. Okay. So this is our approach, and this is how will we solve it. Okay. So yeah, as you can see, the runtime is good as we're beating 100% solution. Okay. So yeah. This is our approach to solve this problem. Okay, so the code link, the question link, the code link will be in the description. That's where you can visit. That's where you can see our code and the question. Okay, so thank you everyone. Have a nice day ahead.